Here we go. Welcome everyone to the fourth GreenPlast webinar. As you may already know, GreenPlast 2022 is the first exhibition revolving around the plastics and rubber sector with a focus on recycle, reuse, energy efficiency and sustainability. It will be held in Milan this year on May 3 to 6, together with Ipakima, Farmintech, Print for All, and Intralogistica Italia. GreenPlast will also host the third edition of Packaging Speaks Green, the international forum on sustainable packaging, including a focus on plastics and recycling. Back to our today's webinar, it will be the fourth of a series of online events that will lead us to GreenPlast. Each exhibitor may have the chance to talk about its production, technologies, innovations that will be displayed during the show. This session will be devoted to injection molding, a process which may be also performed using recycled and bio-based materials. The topics that our guests will introduce today show how their research and development activity has made their technology at the service of the circular economy, complying with the international targets of the so-called ecological transition. Now we have the pleasure to welcome four reputed manufacturers: Arburg, BMB, Engel and Piovan. Before starting, let me remind that for any questions, participants may use the chat. So send us your messages and we will have a scheduled Q&A session after the speeches. Now, let me introduce Mr. Bertram Stern, Sustainability Manager at Arburg. Mr. Stern, welcome. The room is yours.
Good morning. Thank you for the introduction. Let me share my screen so that you can see the presentation. There you go. Just a second. Yeah, welcome everybody. It is my pleasure to introduce to you the Arburg Green World. Arburg Green World is our statement and strategy at the same time related to sustainability, which is a very important topic in these days. And let me introduce you what is about Arburg Green World. The main topic of today's lecture will be turning challenges into opportunities related to the processing of recycled materials. Let me introduce myself real quick. My name is Bertram Stern. I'm with Arburg now since 2016 and responsible and in charge of our sustainability activities, and looking forward to give you an overview what we are doing in this topic. First of all, a quick and brief introduction and overview of the company Arburg. Arburg is located in the south of Germany in the beautiful Black Forest area, as you can see on the picture. This is our headquarters and main facility. All our machines are produced 100% in these facilities. So yeah, 100% made in Germany and 100% made in the Black Forest. We are a producer of injection molding machines, so-called the all-rounder, in a range from clamping forces from 125 kilonewtons up to 6,500 kilonewtons or 650 tons. We have different driving concepts, beginning with the all-drive, which is 100% electrical driven. Then we have a hybrid concept, which means that we inject due to an accumulator to achieve a high injection speed. And then we have, of course, the full hydraulic injection molding machines. Just to give you a brief overview of what we are doing. Some facts and figures. As you have seen on the previous slide, our headquarters in Germany is approximately 210,000 square meter big. We are we have further construction, so we are growing year by year. Then the turnover in 2020, due to the Corona effect, of course, was a bit less than the years before. but we are on good track to achieve the same result as in 2029. So quite happy with the order income in the last year. Export share about 70%, and worldwide we have approximately 3,400 employees worldwide. Coming to my main topic, sustainability, a keyword such as, or keywords such as alternative material, processing, and use of recycling material, the responsible use of raw material, and as well an energy efficiency and legislation are increasingly becoming the focus of processes in industrial companies. And based on this, it is also part of our philosophy, and it is also part of our daily business. So talking about added value, resources, regulation, and circular economy. And to have answers to all these requirements and questions, our solution for these big challenges, and not just big challenges, it's also a great opportunity, is so-called Arburg Green World. And with the Arburg Green World, we're bringing together all of our activities for a greater production and resource efficiency, as well as a more circular economy and a sustainable reduction in the carbon footprint of plastic processing. One topic I mentioned, or one major topic, of course, is the circular economy. Circular economy means to have targeted use and an efficient recycling of plastic. This is crucial to keep the material, the resources in a circle, to contribute to conserving the resourcing during production, and of course establishing recycling system. And last but not least, a circular economy is only possible when the entire value chain or the entire industry have same mindset and working on the same target. So it's it is also crucial to have a close collaboration and communication with all partners along the entire value chain, beginning with material supplier, but also mold makers and peripheral devices supplier. And what does it mean to have a, let's say, a paradigm shift from a linear economy to circular economy? This means that we have to change. We have to get away from a linear value chain where waste is left over at the end, towards a circular economy and action in which products and materials are recycled and reused. And of course, and without a doubt, this is a great challenge and it is a huge task, but it is also, and I want to stress this again, it is also a great opportunity for us, and not only for us, but also for our future. And frankly speaking, there is no alternative to change the way of our economy from a linear to a circular economy. And therefore, let us use this opportunity together, and it will definitely only work if we really work close together and act and take responsibility. And a functioning circular economy, again, is only possible when everybody is working quite close together. But therefore, from our point of view, the focus of circular economy is on the recycling and the processing of recycling material. And what does recycling mean? Does it mean recycling, or how are these materials available and how does these material behave? And therefore, I would like to start with the definition. You see on the left-hand side, the PER, the post-industrial recyclate, and these are collected directly in production as a startup material or as an off-spec product. And this material stream can either be feed back into the process in part, or it is processed again as granulates by service providers. And then on the right-hand side, or otherwise, we speak of the PCR, the post-consumer recyclate, and all plastics that occur at the end user. In Germany, mostly collected in the yellow bag, or it's called the yellow bag. but mostly thermally recycled and not returned to the material cycle in production process. And this is where we need to have our focus on the PCR material. And for a circular economy, these two resources stream must be post-treated. And what does it mean exactly? Let me further introduce you some more definition. Basically, this is done by grinding to get a recycling material. PER or the PCR material are grinded and are then available in a variety of particle size and shapes. And the regrind can either be feed back into production proportionally, or otherwise the regrind is fed into a compounding or extrusion process that then produces granulate again. And this is called the regranulate. And then on the other side, we have additional features and function if additive stabilizers or chemicals are added during the compounding process to build up the chain. The regranulate becomes what it is known as a regrind, and the properties can thus be upgraded. And on the right side, we have the grist with different sizes and shapes. Can also be contaminated with some dust, but it's not, these grist is not compounded and not regrinded. And then in addition, there's also a different definition of terms of the recycling crate in terms of the type. On the left-hand side, we have type pure, which means only one polypropylene, for example, from a raw material manufacturer. And then we have the variety pure. This means only polypropylene, possibly from different raw material manufacturers. Then we have the rarity like. This means polypropylene only, but different. It means only polypropylene, but from different or with different properties. Example of additive, talc, and whatever. And then we have on the right-hand side the most difficult to process, the mixed different plastic. In this case, it means that PP and PE is mixed together and have been recycled, and which is definitely the greatest challenge to process furthermore. This is just an beginning and an overview. What is recycling about and why is it so difficult to process recycling due to the different types, due to the different shape and so on. So recycling means at the end of the day, it is not just the recycling itself. We have, as mentioned, different shape, we have different sizes, but also the composition can vary, and this turns effects on the processing. And due to the large number of requirements and also challenges in the processing of recycling, of the recycling material, Arburg is offering a so-called recycling package or a recycling module on injection unit side, which consisting of hardware and software components for the injection unit to achieve a better or to contribute to a better processing of the recycling material. So basically, what function has a plastification and injection unit regarding the processing of recycling material, and which role is attributed to the plastification? Let me introduce you to these features from hardware and software side on the next slides. Beginning with the hardware, let's look first on the trickle-in behavior first. So the filling or the trickle-in geometry is mostly arranged at a 45-degree angle in most of our plastification. So we come from the all-rounder idea, which should make it possible to use our cylinder modules extremely flexible. But this is not the most flexible solution for preparing regrind, and therewith we have improved, as you can see on the green picture, we have improved the filling geometry. An additional or a vertical hole in the intake area is intended in the 90 degrees angle to improve the trickle-in behavior or the subsequent sliding of the regrind to ensure that especially the grist material is fed properly into the injection unit. But also the conveyor, conveying is important and needs to be focused. So one step further towards the solids handling, the regrind differs in grain shape and size, as mentioned before, so that the transport of these solids can be reduced. And therefore, the conveying of these solids can be improved by an increasing of the friction between the cylinder and the solid itself. And this can be achieved by making grooves into the barrel. And as shown on the picture, the dark green line, and that prevent that the material from circulating, that the material is circulating with the screw rotation, and it helps that the material shall not slip through. But not only modification to the cylinder geometry can improve the feeding behavior, also the screw geometry itself has also an important role in this matter. So what does it mean? A screw with an increased compression is suitable for processing such regrind or recycling material, and therefore we are using a so-called, or we recommend, let's say it like this, a so-called high compression screw. And based on our experience, this ensures an improved melting, but also stands for improved feeding behavior, thanks to its deeper cut feed zone in the screw itself. So this is really a topic of the different shapes and design of the screw itself. Another aspect concerning the processing of regrind that has not been dedusted, their dust content, especially when we processing the grists, can lead to deposits on the screw. And in addition, the recycling or the regrind can also contain impurities that are harmful to the screw and to the barrel as well. And our answer to these deposits and where is the correct use of coating technology, and we therefore recommend a chromium nitride coating, CRN coating, as you can see on the picture, to reduce the deposit formation and also provide an increased wear protection at the same. So this was a really brief overview about our hardware features. And as mentioned in the introduction, we also focusing on software solution coming. So now to the control and software, which also have an impact and also contribute or support the processing of alternative material. And this support includes at the beginning the ramping up of the process, a so-called control soft start through a stable production. What exactly does it mean? Let's have a closer look. So imagine the injection molding machine starting the process or starting up after long standstill. The tool is not yet thermal balanced, the filling behavior changes, and the viscosity changes. So the application engineer must fine-tune and change the parameters such as switching point or holding pressure level so that the cavity is not overfilled right at the beginning. And therefore the multi-stage startup gives the application engineer the opportunity to successfully adjust the parameters one shot by shot basis in order to bring the process into a balance more quickly process, as you can see on the graphic shown in the slide. And focusing on another software feature or assistant, it's called the Screw Pilot, which works like an automatic distance control in your car. So the advantage of this Screw Pilot is it reacts adaptively to dynamic effects. And with regard to the machine control, it always, and this is crucial, it always knows where the screw should be when filling the mold on site. And in this event, or in the event of faults, the target position is checked, so the reproducible mold filling can then be guaranteed. And an additional control function that supports the processing of alternative materials like recycling is the so-called pressure pilot or pressure control. In the injection molding, what does it mean? Let's say quite brief and easily, you are in an injection mode with an increased pressure level and need to downshift to holding pressure. And this means that the control must first reduce the pressure quickly and then switching to dynamic, so-called switch over, to prevent the melt front from undershooting or standing still. And this leads to an improvement in the balance of the tool as well. And then last but not least, the assistant I would like to introduce to you is the so-called reference pilot or reference curve control. This means that the machine knows the distance, in example, the pressure profile in the tool via a sensor, and can react accordingly during the cycle. And however, this requires a sensor in the tool, but this is easily to implement or to adapt or to adjust in the mold. And then which a combination with the assistant can lead to an improved part quality. And this is what I would like to, or what I would like to stress: the combination of software and hardware, and also using sensor technology in the mold, making the mold more intelligent, and combining digitalization and circular economy and alternative material. This is key to success, even in a topic which is quite difficult to handle in these days. So as we have seen, not all the recycling material are the same, because they differ in the shape, in properties, and so on. And due to a modified classification, this seems helpful to improve the feeding and the conveying behavior, as well as the classification behavior itself. And furthermore, the assistance system, which I have shown before, also support the forming of molded parts from the start of the process to a stable process at the end, and having a good result at the end of the day. Nevertheless, let me make it quite easy. If a process is additionally or completely loaded with material of unknown properties or performance, we can unfortunately not assume that the known product quality will remain at the same level. So frankly speaking, and yeah, as keep it in mind, it still means shit in, shit out. Even when we're using a lot of sensors and software control features, hardware features, if the quality of the material is quite bad, we do not get any good results at the end of the day. So recycling material consisting still of macromolecules, and should basically be converted from the solid to the liquid melt state, and finally into the product itself. And yeah, let's keep it easy. Anyway, a recycling material is just a plastic, and therefore let's advance circular economy in the plastic industry. Let's advance it together, work together, and it is a challenge, of course, but it is also a great opportunity to contribute to the conservation of resources. And feel free to ask any question when you have some. Feel free to send me an email, give me a call when you have further questions. It was quite brief overview what we are doing, but whenever you have some more detail, or if you ever want more details, feel free to ask. Yeah, I'm at the end of the presentation. Thank you very much, and looking forward to an open discussion later on. Thanks.
Thank you. Thank you, Mr. Stern, for your interesting speech. And here we go with our next guest, Mr. Lucio Strappazzon, Sales Manager at BMB.
Good morning.
Welcome.
Good morning. I'm Lucio Strappazzon. I will introduce myself shortly. I work in BMB from 2018. My experience in the sector of plastics this year is of 30 years. Before, I was involved in automation. Okay, now I start with our presentation. I will introduce you shortly B&B company. B&B is a family company in Brescia, and I prefer to show you a video that explains what we are doing from 1967, when the company was founded by Mr. Egidio Bugatti, and today in the company.
An identity for a leader. B&B is a leading reality in the production of injection molding machines. Born in 1967 from a family venture, B&B offers itself as a reality with a high technological content and a human know-how that has innovated, transformed and advanced the times. The founder, Mr. Egidio Bugatti, along with his son Marco, have a clear vision on how B&B should work. Their purpose is to offer machines and personal solutions to solve any need in molding. This is possible thanks to a compact group where management and employees have the same values, with a shared responsibility towards the customer, to quality, transparency, reliability and credibility. B&B products are appreciated worldwide for robustness and precision, resulting in machines with very high technology that will perform 24/7 at outstanding performance levels, but also able to achieve low energy consumption. The customers are always at the hub of all our activities, and we take pride in our achievements in finding the best solutions for all of them. The key to our success is in a customer-based service, a business based on a one-to-one dimension that makes us considered as one of the most approachable companies to answer specific questions of customization. Our top quality approach allows extreme flexibility, attention to the customer, and solid research for new technological solutions. We invest constantly in research, innovation and development to always ensure solutions with high performance levels and extraordinary quality. The competence of our technicians and designers represents the plus that guarantees to our customers a service that goes further than the realization of the product and that covers any exigency. Our technical office, organized into mechanical, electrical and software divisions, makes use of the most modern technologies for the planning and the simulation of the various production processes to constantly guarantee the perfection of B&B machines from every aspect. We follow directly all phases of the on-site production process whilst maintaining maximum flexibility and global quality. All levels of B&B production are supported by computer technology and by utilization of the best available materials. This results in the most precise machines with huge productivity and reliability. The assembly is a very precise and careful process, executed with the most sophisticated technologies by highly experienced technicians. The test is scrupulous, the controls and final checks are very attentive. All these meticulous actions render safe and perfect the B&B machines from every aspect. B&B is organised into 4 lines covering 3 production plants. The first 2 plants are dedicated to the assembly and test of the KW series from 160 tonnes to 3,500 tonnes. The EKW full electric series from 70 tonnes to 550 tonnes, and the EKW hybrid series from 250 tonnes to 2,500 tonnes. In the third brand new plant, we assemble and test the very large machines, KX series, over 3,500 tonnes clamp force. With such a vast range, B&B are confident that all our customers' wishes can be met in full and even taken beyond the normal boundaries with our host of special applications and bespoke solutions. B&B's dedicated team who, working in unison, adopt a shared ownership approach that ensure continuous control of their product, constant supervision of accuracy, quality and consistency that create the solid engineering foundations that underpin the longevity of the final product. B&B machines incorporate the very latest technology that is continually developed and refined to ensure optimum performance. All the stages from initial concept through design, manufacturing to finished assembly culminate in the final product now ready for extensive and in-depth testing. Where complete systems are supplied, i.e. machine, mould, robotics and ancillaries, production conditions are replicated to ensure that when it arrives at the customer's plant, it is ready to produce. Each function is subjected to the most rigorous test procedures. Final adjustments are carried out. Such attention to detail guarantees perfect operation, performance and efficiency, and most important, long life, even with the most sophisticated multi-cavity moulds. B&B know at the point of dispatch that they are then supplying their customer with a finished product that will maximise their return on investment. Customers should never feel isolated. We are not only producers, but active partners for the entire life cycle of the machines. Thanks to a global service organisation, B&B is able to follow its customers and its machines very closely, so you're never far from home. Our premises are located in the major manufacturing city of Brescia, which is situated in the industrial heartland of Italy, and it is organised in 3 production units, side by side with modern and functional offices. Sales and after-sales offices placed in important commercial locations create an efficient infrastructure dedicated to the end users. B&B is present all over the world.
Okay, thank you very much for your attention of our presentation. Today we will speak of our full electrical machine dedicated to the process of compostable resin for food use. We take the occasion of Green Plast, and we thank you, Amaplast, like the organization of this first exhibition in Italy, to present our full electric dedicated of this important sector of the plastic injection transformation. Small introduction before to go in the heart of our presentation is that 80% of marine litter comes from the mainland. We are responsible, no chance. 96% of European citizens knows the problem and consider the problem connected to our education. I agree. European community produce laws and laws to combat environment pollution, but apparently all depend on plastics, but it's not like this. How the company can do more to save the world? We try to explain our idea of it. The companies like B&B, like Engel, Arburg, Piovan, has a really key responsibility on it, because all start from us. And after, we are also normal citizens that has a big responsibility to manage the recycle of plastics. But in the beginning, we have to be really, really responsible of what we produce, of what we propose, like sales guys like me. We have to propose sustainability solution. Also, the machine must be sustainability. We have to look for energy saving. We have to look for the product that we put on the market, the plastic product. For this reason, a lot of companies produce new material, raw material from post-consumer, recycling, and so on. A lot of companies produce machine to recycle. We are really good at the moment. We understand the problem, and we are really, really started in the right way. The company that transform the plastic components now put inside, maybe in 80% of the cases, more recycle. We reach 100% now, for example, with air pad for the bottle. But in the same time, there is also the resin that coming from renewable source and consequently easy biodegradable and compostable. Today, we focused on these parts of the plastic transformation. Before to discuss, I will introduce the greenwashing. Greenwashing is a really, really bad behavior that sometimes a lot of company, a lot of people sometimes meet. What is greenwashing? Is the faced ecology and the mere strategy with an aim of interest adopted by some companies with the sole object of appearing sustainable and environmentalist, while in reality they have very different purpose. You have to make attention of this because sometimes it's necessary to observe, to check very well a product or the communication of the company connected of this product. The real emission of CO2 is the real measurement tool for calculating the eco-sustainability of the product and is recycled. Our disappointment in realizing that the greenwashing also exists in a lot of companies, also in our supply chain. For this reason, we decide to show to Green Plus the application that I will describe. We will produce, finally, a real home compostable coffee capsule. The product is developed with the aim of self-decomposition in a maximum 6 months in a normal home composters for organic waste or for traditional organic waste collection. Practically, you can put your coffee capsules in the normal container where you put the fruit, the coffee, the organic waste. The product does not generate post-composting microplastics. This is very important, but can be used as an excellent fertilizer for cultivation in the home garden or here you have one image what after the 6 months, 25.9 weeks, you will find inside of your composter. I think the image speaks alone itself. Benefit of these cups, this is a high shelf life, 12-18 months. The quality of the coffee inside is like the first day for 1 year minimum, and also 1.5 years is very good. We reduce the waste because with the good shelf life, of course, you use every time the product. And the capsules don't require any other packaging because inside there is a barrier that is sufficient to protect the product inside from humidity and oxygen. Okay, circular economy, of course, because there is a simply use of the waste. It is thrown in the organic waste bin for home composting, for waste collection. It does not require any separation of the wet fraction from the plastic fraction. Reduce the production of chemical fertilizers because it's already natural fertilizer. Reduce energy consumption and CO2 emission due to the elimination of the transport and energy needed for recycling. This is true. This is other benefit of the capsule that we will show at in Plast. Here you have a simple image graphic of the circular way of our capsule. We can start our tube where you can see the tree of coffee. The tree of coffee will produce in the second position the coffee after many work from many people. From 2 to 3, we will find our machine. Our machine will prepare the capsules by full electrical machine with 2 injection units, and I will explain why. Why full electric? Why 2 injection units? The product that you can see from 3 to 4 is the capsules that give us the possibility to drink a good coffee. In the end, the capsules will go in the home composter that produce natural fertilizer for the same tree of coffee. Why B&B full electric energy saving series? Many reasons. Torque motor with direct coupling to the plasticizing screw, brushless motor directly coupled to the satellite recirculating roller screws for fast, silent, precise clamping and ejector. Liquid cooled oil bath actuators to guarantee great reliability and respect for the environment. Exclusive use of food-grade lubrication oils, no grease. Recovery of braking energy and re-emission of the energy for the machine or directly on the network. Energy saving and considerable economic saving. This is very important. B&B energy saving as an injection with brushless motor in line with the plasticizing torque motor for the reduction of the moving parts and dimensions. No reducer, no timing belt on the direct drivers for the reduction of the parts and potential braking. Injection pressure for these capsules is very high, around 2000 bar, and the speed around 400 millimeters per second. Our range of the full electrical came from 100 ton to 1000 ton. The screw is very important in this type of transformation because this type of injection process try to produce THF, tetrahydrofuran. What is this? Is a not so good gas that will produce during the plasticizing moment if the material is, the treatment of the material is not so good. The screw, for sure, has an important responsibility on it, and we control the process. The controller is very important in this case because there is a co-injection between 2 materials. In only one page, you can see all data necessary to manage, control all information concerning the 2 injection units. Here you can see what we control in one page, because the really important matter to produce this type of article is that we have to control the hot runner, very high quality hot runner of the mold, with three sections of the hot runner. We open totally the hot runner, and we start with the first material, external material. After we close 50% the hot runner, and we start with high-speed injection with the second material. This is the layer inside in PVOH, we will explain. And after, we will restart with the same material of before. Of course, the machine is able to integrate all other auxiliaries connected, like dryer, in this case, this is the page of Piovan, or thermoregulator. Here you can see the image on your right of the caps broken, where on the violet caps you can see the layer of PVOH. PVOH is the barrier of oxygen and humidity. Its thickness is of 0.05, and the total thickness of the caps is only 0.35 millimeter. You can imagine 3.1 grams is the total weight of the caps. PVOH is a new material for the barrier to the oxygen, and came after AVOH, and is 100 times better. Of course, the machine is able to connect all by OPC-UL. In red, you can see one important information. Energy consumption is 0.32 kilowatt-hour per kilo. That corresponds to, you can see, only a 0.016 kilowatt-hour per pieces, with emission of CO2 footprint only of 0.1 grams of CO2. Consider that normally the emission of CO2 is measured in ton. Yesterday, I tried to calculate how many ton of CO2 we produce with this mold, 16 cavity mold of this product, and is nothing. We thank you, Italy, for giving us the opportunity to transmit this existing adventure. We hope to have managed to convey the same enthusiasm that we captured in this belief and truly compelling and sustainable technology and transformation process. This piece of information related to compostable capsule and to coffee itself makes us understand how much value can be hidden behind a small plastic object, how much care for the environment, how much work and strict regulation are behind its production, transport, storage, and encapsulation to guarantee us an unmissable and pleasant daily moment in respect of health and the environment as our focus here. We thank you. I will close with the production of this article, and we wait to Green Plus on May to see exactly this. Thank you very much.
Thank you. Thank you, Mr. Strappazzon, for your clear contribution. Let's now proceed with Mr. Günther Klammer, Vice President, Plasticizing Systems and Recycling at Engel. Welcome, Mr. Klammer.
Welcome. Thank you. The plastic business is changing dramatically now. And the question is, what can a machine supplier do in order to support you with circular economy solutions? My name is Günther Klammer. Hello, everybody. I'm responsible for plasticizing and circular economy at Engel. I have more than 20 years experience in recycling. And recycling, I never thought that recycling became that big issue in injection molding as well. And therefore, we prepared a small presentation in order to give you a kind of introduction, an overview what we are doing to supply you with different solutions for the circular economy. Also, thanks to Matteo, he helped me to make these nice slides. Thank you very much. So, the presentation will contain the view of the market. Then we'll address the gaps and the solutions to implement recycling concepts, smart machines, opportunities, and Engel as a game changer for different technologies and applications. Let's have a look at the market. How is the market behave? What will be the future? We see a small diagram from company McKinsey, which shows the growth in the plastic industry in general. Globally, figures are drawn here, and we can see that the virgin material is still more or less constant. So there's a certain growth in the next couple of years, but also a decline. And if we look at the big growing, then it is due to chemical recycling and due to mechanical recycling. So, which means both will exist in future, and we have to deal with both technologies. If it is a chemical recycling, the material is like new, so it's like a virgin material, so we do not have to adjust anything, but there is a certain amount of mechanical recycled material, which makes sense to process as well on injection molding machines. If we see on the right side, then we see a list, a table of different numbers of years, and we can see that the collection rates will increase from 52% to 75% and 74% and even more. And the recycling rate has to increase as well, up to 65% in 2030. And in the European Union's meaning, 100% of the recycling, 100% of the material in packaging should be recyclable. So these are the figures, and this is the market situation what we are facing now, and this is a real big game changer. If you look more in detail, which types of or which markets are taking which amount of plastic, then we see on the left hand a number of roughly 51 million tons of total Euro plastic converters demand, which has a big portion in packaging for sure, and followed by buildings and constructions, and then the other markets like automotive or electrical household goods and so on. If you look in detail, which really used recycling material is processed in different goods, we realized that in 2019 there are only 4 million tons are really processed into recycling goods. So, and this figure on the right hand of the slide should give you an overview. What is the most application for recycling material out of post-consumer material? Then we see the buildings industry takes the hugest amount with nearly 50%. So because I think the recycling material has different or less technical properties. And other thing is that the recycling material is almost from a light gray to dark gray. So it's really hard to use recycling material in consumer applications, but there are certain ways to do it. If we look from a different view to this plastic market, and the Alliance to End Plastic Waste addressed it once with different gaps. So, say, why is not more recycling material used in the market? We see in the middle the whole value chain of the recycling material, which means starting as the raw material designed for products, use them and going back into the process. And then we see there are different gaps. First of all is a quantity gap. So we know this, for example, for PET. There are not enough PET available for PET bottles, even not recycling material. Therefore, also the price is increasing in the PET market. Then we have a quality gap. This is related to the use, to the sorting, to the washing, and we need a more or less clean material in order to process it on a machine. For sure, the economic aspects are very, very important, and there's also addressing a design gap. So, which just means the industry or the OEMs has to consider recycling technologies, which means, first of all, making a product design which is able to be recyclable, like an, let's say so, polypropylene film on a polypropylene cup, for example. And the second is making a design which is possible to use recycling materials. So adjust wall thicknesses, for example, or adjusting the product in order to use different technologies for recycling. So there are different gaps, and one gap what is all around the whole value chain is the data gap, which means if there's a possibility to trace the material, then it should be a higher possibility to use them in a recycled way, which means it can be properly used in a similar product or in the same product if the history of the part is well known and traced. So these are the things, and what can a machine builder do for these gaps, for closing these gaps or small gaps, let's say so. One of the first is developing some technologies which are able to run in recycling material, providing technologies for the design and optimize the production. This we're looking more in detail step by step. If we look at the whole value chain, Engel is interacting with, let's say so, with the mechanical recycler. It is, we are also interacting with the brand owners and mostly with the production. We see also on the left-hand side a gray flow from the sorting to the chemical recycling with a new material providing to the market. And there's an additional way for after mechanical recycling to mix to the virgin material in order to dilute the material and having a certain content of recycling material in a virgin material with, let's say so, proper mechanical properties, so with data sheets and all what is needed for the processing. scoping into this circle, we addressing three edges. First of all, creating standards for the processing of regrind and regranulate material and analyzing this kind of material. Second, on the top is the technologies like skin melt or foam melt, or having a multi-layer injection molding as well. And on the right side, the production phase, increasing the process stability, having a adjusted plasticizing unit in material execution, as well as in the design for running different materials with different bulk densities and melting behavior. And if this is not enough, then we have also new machine concepts in order to run a more difficult material. Starting with the analyzing of the mechanical recycling material, what is available on the market, let's say so. First of all, we are facing in the middle of this slide to see the regranulate or the recompound. So if something is added to the recycling material, we call them recompound. And this behaves more or less like a virgin material, but always considering there are some foreign materials inside, so maybe a mixture of different plastics, and also depending on the filtration finds some impurities, let's say so. On the left side, you see the regrind material, which is mostly from a well-sorted material, or very often also production waste or post-industrial waste. It is a grinded material, therefore the flake size is important. The size of the flakes, the thickness, the wall thickness, which influences the bulk density most, and the feeding behavior into the plasticizing unit. But if the material, for example, is washed, then it always have a certain amount of moisture, because it can't be that properly dried, let's say so. There's also a contamination of ink sometimes, so it's depending what was the product, and therefore there are some smaller contaminations. And then there's a kind of material available on the market called agglomerate. Agglomerates are densified films, let's say so, mostly B-oriented polypropylene films from sleeves. And these PP films can be also processed on an injection molding machine. The MFI suits very well for different applications in the injection molding. So therefore we have the different kind of contaminations, and an injection molding machine should be able to deal with this kind of impurities very well. So in order to find the proper solution for the customer, we have also a questionnaire. So we hand over. So if you have a problem, if you like to ask us, you have a certain material, what you can do with that material, or a different way if you have a certain product, and ask us which kind of material can be used. So we are able to assist you in these decisions. Looking at the technologies for using recycling materials, so which is the technologies are related to the mold side, let's say so. So what we can do. First one is e-mold labeling. This contributes for recycling technology because it fulfills the regulations of designed for recycling. So this is obvious, it's clear. Then we have a technology like foam melt, for example. So you put the film into between the cavities and refill it from one side. Therefore, also technologies are possible which the film is on the same base than the material behind. And this is for decorating parts very suitable because the film is almost more thick, let's say so, and has a certain optic, and therefore it's used for decorated parts. And then we have the group for co-injection or skin melt technologies, where the material is inside the part, so you can see it from all sides. You can see the skin layer, which means the skin layer has the optical demands and all the demands what is needed on the surface, and in the wall there is the recycling material. And this is working like that. Very simple principle. On the left, we're going from the left to the right side. On the bottom, you can see the molds and the injection units. You have two of them, one for the skin melt and one for the core component, which means loading the main injection unit with the skin component from the front side, and with the core component from the rear side, and then inject it together into the mold, and then the skin is laying on the wall of the mold, and then the core component is pressed into the center of this. And it is, with this technology, they are able roughly 50 to 60% recycling content in the center, in the middle of the product. You can see this in a picture on the right hand side, on the top, with the green core component and with the white skin. And this gives you an idea what can be done. You can also see ribs are not completely filled with the core component, so the design of the mold is very important. And that's the reason why I mentioned, if the design of a product fits for such a technology, it can be a very proper solution for using more recycling content in such a product. The next, and this is the, let's say so, most interesting point of view for recycling technologies from as a technician, let's say so, to have some adjustments on the injection molding machine in order to be able to handle the various recycling material. And this is the main problem, let's say so. Recycling material varies in different ways, from starting with the bulk density, color, and melt flow index. And for all these variations, systems are needed in order to handle these different behavior of the material. Starting with the Inject 4.0 program, which has different modules which also contribute to the circular economy. It is one idea to analyze everything and measure everything in order to control the process. This is the first thing, and the second thing is to make the process more transparent and see what is going on in the machine. And we have here three different levels. On the bottom is the transparency, the assistance, and the efficiency of the machine. And now we are walking through all these different kind of IQ products for contributing the recycling technologies. We see three of them are more relevant, let's say so. It's the IQ weight control, it's the IQ clamp control, and the process observer. Starting with the IQ weight control means that what is the IQ weight control doing? The situation is, for example, and we showed this already 2 years ago at the last key show, we had a machine there with two hoppers, with two different suppliers of a material. It was a technical polymer, and with these two different suppliers who had two different melt flow indexes. And then we switched over from one to the other hopper, and the machine adjusted the parameters by themselves in order to have always the same shot weight. So the shot weight is influenced by the viscosity most, and this is a problem for recycling material. The shot weight is also influenced by the closing behavior of the non-return valve of different temperatures and ambient conditions. And all these conditions get controlled, let's say so, by the IQ weight control system. And this figure shows how it works. So these two graphs showing the graph above shows the shot weight, and the graph below shows the viscosity, changing from material A to B. And the green line above shows the shot weight with IQ weight control on. So within the shot, the system is able to control the shot weight exactly, and without the shot weight was decreasing dramatically. So this figure show how the IQ weight control unit stabilized the process, even changing the material from material A to B, changing from one raw material supplier to the other one. And this is a very important feature for our customers in order to have the flexibility of different raw material supplier for recycling material. Looking to the clamp control controls the force on the clamp side. So what this has different advantages. Yes, first of all, it regulates the needed energy. So this is also an energy saving system, let's say so. And also it prevents the tooling from different different problems, mainly reduces the wear. And in recycling material, it's also a better venting on the tool side possible with this controlled force. So there are some advantages also for the recycling material using this kind of IQ system in order to control the clamping side properly. Yes, and the IQ process observer is a system which is, let's say so, if you are running a machine, it's really hard to control every parameter on the machine in order to be in the right range and getting out the proper product. And this will become more complicated with recycling material because the more or less constant input material is not longer given. And therefore, there's a need to analyze the data. And this gives you the assurance that the safety that your product is always fine because you have data which shows a proper process, and due to the proper process, a proper product is given as well. So this is the idea of this kind of observer. So you can adjust your own parameters on the system and watching these parameters, and if you are realizing that some of these parameters are completely out of your expectations, then you can interact as the first one, and secondly, you know what was going wrong, and you can adjust the process, changing the material and whatever in order to have a proper and constant quality of your products. And this is a very nice feature, this IQ process observer, because it can be adjusted by the customer side and can be used for a really, really smart and simple tool to observe your process. Okay, these are the ICO-weight control modules, which assist also in the usage of recycling material, let's say so. And now we're going to the more tricky material, input material. So looking at different kind of flake sizes, like it's shown in this picture here. It look like cups from my point of view, different sizes, long parts here. So the feeding behavior, it's maybe difficulty for this kind of material, for example, but it looks very clean and nice. And yes, the color will be one problem as well. And if we run such kind of materials or materials like the agglomerate or a different recycling material, then some additional system should be installed on an injection molding machine. This can be either a dosing for the feeding and hungry feeding the system, because due to this there is a certain opportunity to have a backwards venting and also to have always the proper portion in the screw. The IQ systems, weight control, it's obvious, and two further systems should be implemented on the injection molding, which means the degassing and the filtering on the system. So how does it look like? So it is a technology which is quite well known in the market, which is a plasticizing unit and using an injection piston. But this can be also changed by the feeding screw or injection screw, let's say so. We have here two systems available, depending what is needed for the product. And then we have, due to this concept, the possibility to add a filter or a venting section or add some additives on different points in this concept. And I just want to show you one result what we made with the venting. And this picture is from our development department, which making some analysis of the venting ability on an injection molding machine. And this shows on the left-hand side a part which was not vented. It was with roughly 1% of moisture. We put the moisture in with natural fibers in order to see to have a proper distribution of this moisture in the material, and then we're realizing there is a big forming. And then we have a particular filling of the screw. So we reducing the filling of the screw, and due to the reduced filling, we have a certain free area, and then we just let this the gases out to an opening in the barrel. So just via the opening, and then we got a proper venting only to relieving the moisture. And the next step was adding a vacuum pump, which is commonly used in the recycling technology. So adding a venting port on the injection screw in order to remove with a vacuum pump the moisture content. And this also gave a very good result. So what we can say, we have available technologies which are able to reduce 1% moisture from the material. I hope this is never used, because 1% moisture is quite a lot. Normally we're discussing about the much lower levels. If it's coming from a washing line, it has to be much lower, but it was a principle test what is possible. Okay, and if you're using this technology and running flakes directly into the injection molding process, we save the regranulation process, which means all the energy what is needed for melting the material and cooling down. So let's say roughly 400 watt-hours per kilogram can be saved if running flakes directly in the injection molding machine. And therefore, it's also a reduction of the carbon footprint of the product. And this is One of the advantages, or the most obvious advantage of these systems, but there are several other advantages in terms of reducing input material costs, also in reducing footprint, for example, or general energy consumption for this kind of machine in a two-stage process, which is an additional concept to the single-stage process, which a recycling material is also available to get processed. So let me summarize. We have here the analyzing what has Engel done, and these activities are for our customers, these activities for you, to help you in the analyzing of the recycling material, to get ideas what can be done with this kind of material and process it stable in your system with proper machine solution and IQ system. And if this does not fulfill your demands and you're needing need to process a cheaper material or have higher demands on your quality, then we are offering different technologies for the hiding of the recycling material, or venting and filtrate the recycling material for an excellent product. Thank you for the listening.
Thank you, Mr. Klammer, for your interesting speech. And now, last but not least, I would like to introduce Mr. Pavel Andrushchuk, Business Development for Recycling at Piovan. Here is Mr. Andrushchuk. The room is yours.
Good morning. Hello to everybody. My greetings to all participants of this new edition of webinar introducing Green Plastic exhibition. Particular gratitude to organizer and other speakers who widely and professionally introduce the topic. My name is Pavel Andrushchuk. I'm 15 years in plastic industry, taking care of sales of auxiliary equipment, and I'm in charge for development for recycling business of Piovan Group. Today, we will continue to speak about eco-sustainability. Here we are with presentation. Eco-sustainability, plastic recycling, and the use of post-consumer plastic in injection process, but from different perspective of auxiliary equipment and industrial automation. So, few slides about Piovan Group. Piovan Group is a world leader in development and production of auxiliary equipment and automation for plastic processing, but not only, food industry and industrial refrigeration. Recycling of plastic is one of many industries where Piovan operates. However, recycling accumulates and take benefit of experience of all other sectors, including handling, storage of food products as well, and also industrial code required for all recycling applications. Few words about our global presence, which is one of the main characteristics of Piovan Group, besides our dimension and experience. Let me remind that over 60 years in plastic field, and like dimension, we are approaching 2,000 employees. So one of other characteristics is our global presence, which is particularly important for the industries we are dealing with. We are present on every continent with at least one production unit. So in totally, we have 14 manufacturing facilities and over 100 presence between direct branches and commercial representativities. Let me mention the most interesting involved in our recycling industry. In Germany, we have a factory, a company, FDM, which stands for feeding, dosing, mixing. In Italy, we have Penta at Ferrara, particularly specialized in storage and handling of the most complicated substances as powder and flour. Also, a new acquisition of American companies, IPEG Conair, includes Pelletron, company Pelletron, who is famous for one of the best dedusting solutions on the market. Also, it's widely known and requested for recycling application. Another characteristic of Piovan Group is our believing in research and development. We have over 200 engineers, including research and development and technical department, and we invest about 4% in our R&D activities, which seen a good part of the patents in recent years around the circular economy and recycling in particular. Now, let me add my tribute on eco-sustainability of the plastic, in addition to what my colleague said previously. So let's take as example half-liter bottle, like a most representative of the plastic in our life. Everybody has, also I have on my desk, like every speakers, and this product, let's say, is the best demonstration of importance of plastic in our life. So as you can judge from this slide, our plastic bottle weighs several times less than its equivalent made with paper, aluminium, and glass above all. So it's few tenths of times bigger than weight of plastic. In addition to that, for melt, the plastic requires much less energy. Finally, contrary to common thinking, our plastic bottle produces much less CO2 than its sister. So the carbon footprint is much smaller. Using recycling plastic reduce CO2 emission compared to virgin plastic because the most of releasing of greenhouse gases are in phase of extraction. So we are cutting this phase. Now, this slide you already saw from Mr. Klammer presentation. It's not that somebody copied presentation, but Engel and Piovan attend probably to the same sources for planned global development. So the point is that we expect, so the essence of this message, in 2050, we expect to have roughly 60% of total plastic in circulation coming from recycling and from reusing. So for sure, such increasing of recycled plastic is a big challenge for recyclers, converters, and first of all, for us, for my colleague manufacturers of machinery, and it's only beginning of this challenge. Now, before we move strictly to technical content, I want to underline that Piovan is particularly involved both in the recycling of plastic and converting, that it's the using of post-consumer plastics. In average, 1 of 2 bottles in circulation in the world in recent plants have been made with the usage of Piovan equipment, and with coming with popularity of bottle-to-bottle recycling, this part is destined to grow. And probably because we accumulated experience of both sides of supply chain, we are together. Let me remind that Piovan is supplying the most important producer of recycling lines from Austria, from Europe and worldwide. And we are also providing auxiliaries for transformers, for so-called converters, which process the plastic. Now, what are the particular focus for Piovan in development of machinery which use recycled plastic? So, first of all, it's about dedicated solution which post-consume plastic, because post-consume plastic represent difficulties in production. The mixture often is not homogeneous, dusty, material can agglomerate, has trouble in flowing and so on. Obviously, must be implemented system for control and reduce the contaminants, which another very serious issue. Also, important point that it's requested control automation for track and for monitoring of process parameter of the product. Not less important point, since such complication arise and challenge from the market grows, also maintenance necessity are growing and maintenance capacity have to be increased. Last but not least, new technology is requested for face all these challenges, and that's why recent patents in possession of Piovan Group are coming properly for recycling field and for circular economy. Let's better describe which are the challenges for using of recycling material for us, for producer of automation and auxiliary equipment. So first, degradation of capex, a reduction of life cycle of machinery because of huge growing of dustness, presence of contamination, irregular behavior of materials such as flakes and so on. Material maintenance grows significantly, and the life cycle of machinery can even come to 50% of normal one. Another thing, second thing, is not continuous quality of the lots. This point was widely introduced by my colleague from Arburg about non-continuous batch of material, and due to this we have discontinuity in characteristic of product we inject. So scraps caused by quality of material or non-continuous process is difficult to guide, and scraps can grow even by several percent point. And finally, when we solve first 2 points, we still have to fight against contamination. Contamination, if it's mechanical, it can involve mechanical deformities, black spots, and so on. Meanwhile, chemical contaminants can give us, for our packaging, the danger for the drink we have inside our container, and also all derivating reputation damage and so on and so on. This is example on the picture on this slide. You can see example what happened to several common parts of our equipment, in general, which is in contact with the air which treat recycled plastic. So you can see on upper side picture of exchanger of molecular sieves inside dryer and of the filter. Attention, this is only about the contact with the air. So no material touching this part, but only the air which was in contact with recycled material. So you can judge from below photo that molecular sieves became brown color because of contaminants, because of VOC, volatile organic compounds, adsorbed from the air. On the cold surface of exchanger, you can notice so-called chemical honey, which is condensated from VOC. And on the filter, we can see deposits. Of course, such deposits compromise performance of the filter itself. So the problem of recycled, of post-consumer plastic are closely connected to its previous life. The plastic of the bottle or any kind of container interact continuously with the content inside, with the drink, and vice versa. So-called NIAS, not intentionally added substances, migrates from drink into the bottle and subsequently from the bottle inside the drink in next reincarnation of the plastic. This phenomena is intensified for sweet drinks and intensified much more for other type, for aggressive liquids, especially detergent and so on. Obviously, in the use of recycled plastic, there is a great discontinuity of characteristic between various batch. Okay, at this point you see in Mr. Stern's presentation. So, how we deal with all this problem? In order to face this problem about recycling material, we have number of technologies, a wide range of products which are developed properly around this problem. Now you can see on the slide moving different name of different devices, equipment, technology, or integrated system, which are created for face of this point, this compatibility with recycled plastic. So between them, between sophisticated algorithm for PET, for rPET, you can see also more common device like, for example, storage, dosing equipment, feeding, temperature controllers, cooling, but also, last but not least, supervising system. It's about Lean Factory 4.0, which is Piovan supervising system capable to trace each product characteristic and each batch of material with parameter of equipment, with history of alarms and so on. To this, we can add laboratory instrument, which is monitoring different characteristics of the products, and come even to monitoring, to audit of operator and all operation with our machinery. So these technologies and this kind of supervising, we are supplying already to our customer from pharmaceutical, automotive, and food industry, and of course it's available for recycling as well. Now, since it's not the time and occasion to introduce all product range, for this I hope to see you during Green Plast exhibition. So here we can see just a flow, a macro flow of processes for injection of post-consumer plastic. First of all, PCR, post-consumer granules, can be analyzed by our laboratory instrument. The name is Inspecta, which can analyze certain type of contaminant, certain type of VOC. The next stage could be deodorizing for polyolefin for remove the smell from recycled granules. It could be crystallizing for fight against amorphous structure of material, dehumidifying for take out humidity, then chemical characteristic can be cross-analyzed by interacting with injection pressure of machine. Removal of chemical contaminants can be done during air purification with so-called PureTech active carbon filters, which could be integrated in drying phase and inside condensing of the air from closed circuit process, as could be drying process. Then, in order to ensure constant quality of molding process without machine downtime, avoiding contamination, we cross all this data, all this process in one loop. Above all of this, as I mentioned from previous slide, we have Refactory 4.0 supervising, which track any change of the process, any change of parameter for process and for product as well, and keep history of all this change. So this is our, let's say, our technology available to work with post-consumer plastic. This machine, Inspector, which you see on the slide, is no other than a portable laboratory, which born as per request of our customers, brand owners, bottlers, who particularly take care about our health. So with simple procedures, which can be available to basic operator, we are able, with this machine, we are able to detect the presence of VOC, for example, acetaldehyde or benzene, to track it in a very short time, less than 60 minutes, and make accurate test for all kind of, let's say, of input. So we can do it for granules at early stage during recycling process. We can do it with preform. So when the product, when plastic has been converted, so we can put inside the preform for detect presence of benzene, or we can cut piece of bottle or piece of extruded sheet. So this is about Inspector, which, let me remind that what this machine, this equipment was between a finalist of 2021 Sustainability Award. Sustainability is a thing which goes through all the phase, all the product of Piovan Group production, and also it became characteristic of the group. On this slide, you can see information about ESG rating, which stands for Environment, Social Governance. This is a rating which we obtained recently from Sustainalytics, which is part of Morningstar company. And this high rating which we receive is particularly high because basically 9 of 10 companies are behind Piovan. So starting to conclude my presentation, let me summarize, let me say that Piovan Group is sustainable operator in production of auxiliary machine and industrial automation destinated for the massive usage of recycled plastic. So concluding my presentation, thanks so much for your attention. I am at your disposal for answer on any question. You can see on this slide my contact data for further inquiries. And let me thank you again for your attention and wish a good luck to everybody in our common business to save the planet.
Thank you. Thank you, Mr. Andrushchuk, for your valuable presentation and wishes. And now we have a quick Q&A session. Before starting, I would suggest speakers to switch their camera on. We had a first question for Arburg, but unfortunately Mr. Stern had to leave our webinar, so we will forward him the query for a direct answer. I would proceed with the BNB. Mr. Strappazzon, if you are ready, I would ask you the question we have received. So, do you think that the bioplastic or better compostable plastic will be the main way to follow in order to reduce the problem of the plastic waste that we are living today?
Yes, I think, but no possible to think in this way. I think today the main way to follow is what we are discussing mainly today: recycled material. We have to be able to recycle all, and of course the natural fibers, bio-based, are maybe the best, but today the cost still is too high. Maybe there is also some politician agreement not ready. And for this reason, I think that the post-consumer material and recycle is the main way today. But I want to addition only one needs. In my opinion, if we speak about post-consumer, if we speak about recycle, we have to speak about education, our education. And today I see the young generation. I have also two young hands that maybe from the school or around the world, plastics is like an enemy. This is not true. We cannot take out the plastic. It's too important for our future. And in my opinion, today, all we explain what we think about it, and we have to convince, to push the government to teach this matter, at school from 6 years old. This is a way to make the exam in order to have a new generation really prepared, really responsible against the recycle of plastics. This is what I think. Thank you very much, and arrivederci.
Yes, sure, education is essential. So now we have a question for Engel. Mr. Klammer, would you like to join me?
Yes.
Okay. The question is, we see your two-stage process that can run with flakes. Is this the future for all recycled materials?
It is a certain future for a special kind of materials, mostly materials what are well sorted, let's say so, and with a certain contamination. It is a solution if somebody wants to have a higher quality of the product in terms of venting and decontamination with filtering. It will never become a solution for everything and for all, because recycling is very difficult, a lot of different material streams, but we see also a lot of activities in order to get better sorting, to get a proper material stream, and then we really believe that this will be able to handle material streams for different products like pallets, for example, or all other thin-walled products for logistic and all such application. We are working already on these projects, and for this is a very nice and proper solution, let's say so. It's never like that one technology covers everything, so can't be. The world is not that simple.
Okay, thank you. And now last question for Mr. Andrushchuk. Are you ready, Pavel?
Here we are.
In its presentation, Piovan talked about instruments for the detection of contaminants. Whom is this tool addressed to? The recycler, the producer of post-consumer material, or the converter who uses it?
Thank you for this question. A really great question, which still doesn't have answer, like also question, how many times can we recycle our bottle? So basically, what we see from our experience, from our sales, basically that the issue of detecting of contaminants belong to all these parts, to all players. So there are responsible recyclers who adopt such instruments, who has a laboratory bigger or smaller. And there are also converters who adopt instruments like our inspector in order to detect presence of benzene, acetaldehyde, and so on. Unfortunately, since recycling is a relatively young industry, there is no yet scientific or legislative basis and standard which could impose limit value for all the players of this market. That's why in the market there is a presence of somebody who has, let's say, Austrian line paid few million, somebody who has line which cost much less, and apparently both of them produce the granules. And if you see, granules can even look the same. At the end of this, what makes the difference is the presence of contaminants and characteristic of material. That's why what I can say, processor converter have a big headache dealing with different from different sources. Of course, there is also shortage of recycled material because there is certain rally to increase the percentage of rPET in the bottle and in any product. So to make a long answer short, the responsibility actually belongs to both sides, to who produce recycled material and to who consume recycled material, since there is no clear basis which says exact limit values for this, but it's have to come in any case. Thank you for question again.
Good. So that's all. I would like to thank our panelists and all the participants in our today's webinar. It has been recorded and the file will be available in our website shortly. We are already working on the next webinar in March, focused on our interesting topics. And for further details, stay tuned on our channels, the website greenplast.org, socials, newsletter. And if you have any question, please write an email to our address info@greenplast.org. Have a good day and see you in Milan for Greenplast.